Hi, my name is Krishna Maran and this is my Physics Lab 2 report. In this lab, I observed the motion of an object dropping from rest, falling somewhat slowly, meaning it had some air resistance as it went down. So the object I used was a paper crumpled ball. I analyzed the video of this in the platform called Tracker to find the object's final observed position and compare this with the predicted position with the gravitational force and with the gravitational force plus the drag force. So I created two computational models constructed using the momentum principle to show the effect of gravity and the drag force. So the purpose of this was to determine if the terminal velocity was reached for this object in free fall, and also to compare the free falling object with and without drag force to the observed data. So it took a roughly 0.667 seconds for the object to hit the ground, and the observed position was negative 1.535 meters, and the predicted position with just gravity was negative 2.953 meters, and the predicted position with gravity and the drag force was a negative 1.493 meters. The data shows that the observed and the drag force graphs both reach a terminal velocity at around t equals 0.5 seconds. However, the graph that has without drag force does not reach a terminal velocity because the gravitational force always increases the velocity of the object falling. So that will always be increasing speed. One problem that could have happened with the observations that I made was that the y-axis, as you can see in the image in the top right, is tilted, and this had to be done because the phone camera was also slightly tilted while I was recording the video. Therefore, it didn't fall completely straight, which could have affected the data. Additionally, the point mass for each of the frames that I put in was estimated, not calculated, so that also has human error in it as well, which could have changed the data. So as you can see in the graph, the observed graph actually had more drag than the graph that was a computational model with drag force. So if my observed data was completely correct, it would have lined up perfectly with the drag force, but the drag force computational model underestimated the drag force, which means I think a reason for this increase in time is because it wasn't falling completely straight in my observed video. So the two graphs that I saw that had a terminal velocity were the observed and the predicted with drag force graphs. They were not the same value, but at around 0.5 seconds, they both hit a terminal velocity. In the observed graphs, it was roughly 3.6 meters per second, and in the predicted with drag force graph, it was roughly 3.15 meters per second. Now let's explore the computational model without drag force. So first, in the top half of the code, I inserted the paper ball's mass and I changed delta t to match the tracker's video's increment, which was 1/3 of 1 second. The initial position was the origin, and since it was falling from rest, the initial velocity was also 0. Now in the bottom half, I had to include the weight force formula, which was the net force. So that was the ball's mass times gravity times the unit vector for the y-axis, and this was not positive since it's going downward. The computational model with drag force is almost the same in the top half, except now we've added b, which is the proportionality constant for the magnitude of the drag force. So as you can see in the while loop in the bottom half, the drag force is equal to the velocity squared multiplied by the unit vector of the y-axis multiplied by b. This whole thing is also not positive since the object is falling downwards. So b is 0.0026, and we found this by trial and error, and we did this until the final position in the output was as close to the observed position as possible. Now let's explore what would happen if the object was thrown instead of being dropped from rest. So as you can see, the initial velocity was changed to a negative 1 meters per second in the y direction. And as you can see in the graph, it falls about 0.3 meters farther in the same time frame, and it actually hits the terminal velocity quicker than in the code with the drag force by about 0.1 seconds. Through this lab, the main thing we have learned is that an object with drag force will have a terminal velocity no matter what the initial velocity is. Thank you for your time.